Hi everyone, welcome to another video. In this video, hopefully we will, in a short and sort of concise manner, discuss some of the data displays we've learnt in the past. So this video is kind of like a revision of what we've done before. And we're also going to look at these through the context of the types of data we learnt in the last video. Now, jumping straight into it, we are going to reintroduce some single variable sets of data. What I mean by that is there's just one kind of thing we're measuring. So there is a single kind of element here. For example, number of cars a family owns, something like that. Now, a couple of these that we've got here, we have dot plots, which we remember we mark out the frequency sort of on this height axis. And so how many of each we have. And this little x-axis here, this is the score or the thing we're essentially measuring. So something like this could be, for example, the number of pets owned in a household. The next one, stem and leaf plots, we remember these as having a stem element here as well as a leaf element, where in the context of numbers, this just gives out some numerical number values. So these could be like scores in a maths test, where the first column, this is the digit, like if these were 2-digit numbers, this would be the first digit, and then the one here would be the second digit. So this would be a score of 3, for example. Or if I took, for example, this one here and this one, this would be a score of 27. So this is how we can interpret these. We've done these in depth before, so this is really just a bit of a revision. And finally, we had column graphs. So we had an example of this is we have our score on our x-axis, our frequency on our y-axis, and these little columns just show what our frequency was for the low score, what our frequency was for a high score, how many people answered this. Now, these graphs, looking back to what we did last video, these are used to show a single set of categorical or discrete data. So these two, for example, up the top, these would be discrete because our numbers here that we've measured, 1, 2, 3, or 4, we are numerically plotting things on the graph, and we're looking at the frequency of those scores. So the values are going to be discrete counting numbers, 1 through 4. The stem and leaf plot as well scores on a math test. So they're these single discrete scores. A column graph, for example, this is a categorical type because there's no numbers associated down here. These are, we have categories. So I don't know, say this is like the, this could show a, like a customer service survey. In which, when you leave the place, you rate, for example, what was the level of our customer service? So low, medium, or high. And the people that voted are shown up here, the amount of people that voted for each. Now, something like this would be categorical because we've got categories here, but there is a type of order to these things, low, up to medium, up to high. So this thing here, this would be a categorical ordinal type of data representation tool. So these are some that we looked at. Another, explicitly defining this, is a thing called the histogram. And this thing can be used for grouped, discrete, or continuous numerical data. So if we, for example, had we can use this for individual numbers, or we can also include ranges, for example. So say we had an interval of 10, for example, between all of our values. So if I drew up a little table here, if I had my score, my frequency, and I don't know, percentage frequency. Actually, let's not complicate this too much. My score and frequency here. So, I don't know, my score can be, for example, 1. But this is showing an interval of 10. So 1 to 10, or maybe 10 to 20, 2, 3, and 4. And all of these different values can be plotted on my histogram. So say I had, I don't know, 3, 5, 3, 4, and I show a histogram. This is like a type of column graph. So if I have my frequency here, I have a score of 1, 2, 3, and 4. I can show this on a bar graph. Not a bar graph, on a histogram. And 3 would be, I don't know, around here again, and then 4 would be about here. So if we have 3, 4, and 5 here, now I'm just drawing a rough one, but we can kind of show how data spreads, which I'm going to be talking about at the end of this video and a lot later in this series. So this is like a type of histogram. And it's going to graph my score along with the particular frequency. How often does it occur? Now, histograms are really great because they can really nicely visualize data skewing. So this is something we're going to talk about a lot, but if we have data skewing, this talks about the shape of our data. So let me draw a couple of examples and see if you guys notice anything happening here. So we have this. This guy over here, I can see the data looks quite symmetrical. So over here, I'm going to write it's symmetrical. Why? Because if I, for example, drew a mirror here, a type of axis of symmetry, everything on the right hand side looks the same as on the left hand side. It's mirrored along this line down the middle. Now if I draw another type, let's see how this thing looks, and we'll introduce this type of data. So here we've got, let's do something that looks like this. Okay, almost done. Okay, this guy here, let's look at what this is actually showing us in terms of data. It's saying that there's a lot of things kind of bunched up around here. Notice that the majority of the scores are located sort of on this end of the graph. And then the graph sort of tails off in this direction. So it sort of drops down. So on the right hand side, it tails off a bit. So there are less frequent values in these two here. The majority are kind of clumped around these 3. Now what we call this one is a data set that is positively skewed. So what we mean by that is it's all to do with how the data tails off. Now, the way I like to remember this one is if we looked at this as an x-axis, the positive x values go on the right direction, the right-hand side. So if we drew a little thing like this over it, my data set tails off, my frequency values drop, they tail off in the positive x direction. Now, if we have a different type of data here, this is to show you the kind of variation, how different this can look. Introducing one more type of data, let's say we have this guy over here. Okay, so something like this, I have, and see the majority of my data clumping up on this side. Because remember, my y-axis is always going to be the frequency. How many people, for example, voted for a particular score. So the higher frequency, the most responses are happening over here. And we're tailing off in this particular direction. So my tail goes in the left-hand direction. So if I drew this here to show sort of this curve just sitting on top of all the values, this is something that skews off in the negative x direction. So we call this something that is negatively skewed. So all of these different types of data we show, now there are a couple more as well that we'll cover all in good time, but these three are particularly well represented with my histograms. So if I draw these and I sort of look at, I try to visualize this a bit better by maybe tracing a curve over showing these changes in frequency values, or here, I can pretty clearly see they all move in quite different directions. The symmetrical sits very nicely, where on either side of this sort of axis of symmetry, my two bits look the same. They're very, very symmetrical. Positively skewed has a lot of data clumping up around these values here. This is where the majority of the data is kind of bulking up together, and then it tails off in the positive x direction. Whereas for negatively skewed, a lot of my data values are around this kind of end, where I have the majority of my responses lying. So my frequency, the higher I go up this axis, the more responses I'm going to get. So I can see my data clumps up on this side and tails off in the negative x direction. So this is how we can remember what is positively skewed and what is negatively skewed. But we'll explore these a lot later in this series, as well as some of these types of data representation. But this particular idea of symmetry and shape of data can give us really big insights into our sample space, our data set, the people we have surveyed here. So that brings us to the end of this video, and I will see you in the next one.